yet. Hard to say at this point. So, while they're figuring out where extra packets are, we can move on dealing with shelf life and skipping that. So, first of all, shelf life is directly related to degradation, or how fast things go bad, because all food eventually degrades. And degrading is going to be change in flavor, smell, texture, appearance. And it generally implies that we've got some organisms that are growing on and in the food, which makes it unfit to eat.
We're on the same.
Perfect, thank you. This is directly related to shelf life, which is the amount of time a food can be stored before degrading. We're going to talk about some of the different ways that manufacturers manipulate the food and the way that it is packaged in a way that we can increase the shelf life, so decrease the rate at which something degrades. For instance, in our emergency kit back home, we now have a can of pre-cooked bacon that's supposed to last for 13 years. Because you can't deal with an emergency without bacon. I know we haven't tried it yet, but yeah, 13 years that this bacon is supposed to be good for because of the ways the manufacturers have increased its shelf life. Yeah. I agree with both of those statements. The longer the shelf life, the better it is for producers. Clearly, they want something that can be out on the shelf for a long time. That way, if Target or Rainbow or Cub buy something and they buy too much, they still want to be able to sell it at the price that they would normally sell it at, rather than have to reduce the price to get it off their shelves quick because it's nearing the shelf life. So it's good for both the producers as well as for the people that are selling it. So some of the things that can happen, we can have a change in the water content. For instance, if we have a wet food that loses its water, there's going to be some changes to it and it's likely going to not taste as good for us anymore. One of the reasons being, as it's losing water, if it had water to start with, we're increasing the rate of the oxidation that's occurring. It's also decreasing the nutrient value. So all of those healthy vitamins and minerals that are in that system, let's say a carrot, as the water evaporates out of it, a lot of those minerals and vitamins are leaving with it, so it's not as healthy for us anymore. We often see decolorization. So again, thinking about that carrot, it's that nice orange color when you first get it, but as it gets dry, it becomes more white. And that's because we're losing a lot of those nutrients. We're increasing the rate of oxidation. If we've got lipids, then we're going to be decomposing those lipids for rancidity, which we talked about last week, which we know produces all of those undesirable odors and flavors. It's nature's way of tipping us off to the fact that it's probably getting less safe for us to eat. We can also have dry food gaining water, so potato chips. You leave those out for too long, it's a hot, humid day, you go back to eat some later, they're kind of mushy. Not as crunchy as they were before. That would be an example of dry food gaining water. So it's becoming moist. And once it does become moist, as this water gets into the system, it's vulnerable to microbial degradation. So microbes get in, breaks up the substance that's in there. It's less healthy for us. Depending on the microbes that are there, the organisms that are there, we can get sick from them. Okay, so we can have degradation with these changes in water content. We can also have chemical reactions occurring. So we can have a pH change. It's like your milk when it starts to go sour. Tastes a little funny. That's when you know you should stop drinking it and get rid of it. That flavor changes because we're having a change in the pH. There could be other undesirable flavors that occur when we have chemical reactions, like that oxidative rancidity. And those carboxylic acid radicals come off. Sometimes we'll see color changes. Maybe the color change is just like the carrot. Maybe it's because your nice chunk of cheddar cheese now has a bunch of black mold on it. Whenever we have these chemical reactions, we're going to decrease the nutritional value again. And if we've got it in the presence of oxygen, we know that we can undergo oxidation, particularly if we have lipids. So we have moisture changing degradation. We've got other chemical reactions changing the degradation. We also can involve light. So if we have more light around, we can have more photochemical reactions. Light is going to aid in that rancidity process. It's easier to break those double bonds in those lipids when we have some UV light coming in. So keeping your butter in a buttered dish as opposed to out on the table can be helpful. We can also see fading colors because of light, which may or may not be due to photochemical reactions, but is generally a good tip-off that it might not be as good for us to eat anymore. And light can aid in that oxidation reaction, which again could either be with rancidity or just different oxidation reactions. In addition to chemical reactions and light reactions, we can also be affected by the temperature. We know that rates of reactions are affected by temperature. We know that as we increase temperature, we tend to have a faster rate of reaction because we're putting more energy into the system, so there's less energy required to overcome that activation energy. So an increase in temperature is going to generally increase the rate of degradation. Changing temperature can also change the intermolecular forces that are involved with water and the other molecules that are in a food, which can then change the temperature, softness, and juiciness of things, especially with meats. You read about that in the barbecue reading. Okay, we've talked about rancidity a lot already, but we're going to rehash it at least one more time. We can have hydrolytic rancidity, where we've got those ester bonds broken down in the presence of lipase, which we talked about being a enzyme. Enzyme reduces the activation energy, it acts as a catalyst. We also need heat and moisture for this reaction, and then we get those free fatty acids or radicals of fatty acids. And those radicals of fatty acids give off that odd smell and odd flavor and are a tip to us that the food's not as good anymore. So the lipase, that enzyme that acts as a catalyst, is produced by many microorganisms and actually is an important part of our digestion. And when it's in our system and we're breaking these things down, that's a good thing. When it's microorganisms that are out on my beef that I have on my tabletop and it starts smelling, that's not so good. Then we have oxidative rancidity or autooxidation, which we learned about in organic chemistry as well. It's that reaction of the carbon-carbon double bond with oxygen in the air, producing a free radical. We get a free radical reaction. We're not going to watch the video again, but if you need a refresher on what a free radical reaction is, you can watch that Hello Kitty one that we watched during the organic chemistry unit. So manufacturers want to cut down on as much of this stuff as possible so that they can keep their products on the shelf for a longer period of time, so that they can sell it for a longer period of time. So some of the things that they resort to is changing the packaging. For instance, they might use an opaque container because they know that it's going to cut down on the amount of UV light that reaches the substance, so we won't have as much of that photochemical reaction going on. A lot of manufacturers will put their products in gas impermeable containers, so ones where the air is not going to react with the substance, and so we won't have that oxidation reaction occurring. And it'll also keep out the water that's in the air around us. So we're not going to have dry foods that are suddenly wet and wet foods that are suddenly dry because they've lost all of their own water. Thinking about those potato chips again, a lot of them are in opaque containers, and they're also in a nice big bag that looks like it's filled with air, but it's actually filled with argon for most of them until you open it up. And they like it poofy because the poofy means that the potato chips are going to stay in one piece easier as they're being shipped from one part of the country to the other, because there's more stuff around them so that they're not getting crushed all the time. But it's not putting air into the system, that air that would cause the oxidation reactions. We put argon in instead. It's noble gas, it's non-reactive, it's not going to have all of those reactions occurring. The minute, though, that you take it home and you open it up, if you don't seal it nicely, that's when you get those chips that are stale, because they've taken in moisture. Okay, storage is also going to play a big factor, and this is going to be storage that the manufacturers have prior to sending it out to the sellers have, and then often recommendations for how you should store your stuff. For instance, refrigeration reduces the rates of many reactions. That should be rates, not rater. Rates of many reactions. A lot of things we want to store in dark places, like that butter. Want it in a container as opposed to just out to reduce the photochemical reactions. And sometimes we need to make sure things are in dry areas. Thank goodness for refrigeration. I can't imagine life without it. Manufacturers and chemists are getting smart. They're figuring out ways to add things so that things stay longer. Actually, some of these things have been figured out hundreds and thousands of years ago. So they can do additives. And those are substances added to increase shelf life. For instance, salt. It's been used for so long. Adding salt to substances like pickling or making jerky out of your meat so it lasts a long time. Sugar can increase shelf life, especially in different sorts of pickling. Sometimes we can add sulfur compounds or nitrate compounds, depending on the food, to increase their life as well. In addition to those, there are steps that we can take and products that we may add to decrease the amount of microorganisms that are formed. So we can do pickling. It's going to discourage mold and bacterial growth. We can ferment something that's going to produce ethanol, and it's going to limit bacterial growth. It's going to kill off those bacteria. And we can add antioxidants. Adding antioxidants is going to delay oxidation by bonding with free radicals that are in the system. And I think the video is going to pop up before the last bit.
My name is Wendell Canihans. I work in the product management area, focused on antioxidants, enzymes, and a few other products. The antioxidant products, as they're looked at from nutritionists and from feed producers' perspective, are a very interesting category. If you just look at the AgriStats data, for example, things like antioxidants and mold inhibitors and other items that don't have a true nutritional direct contribution don't get credit for energy or vitamins, etc., in the animal model. So when I look at antioxidants, what they do is make the other ingredients work better. But when you look at antioxidants, what we do is take the investment in vitamin E, for example, and make sure that the full potential of that makes it into the animal system, as opposed to it degrading with oxidation. When we have an antioxidant in that system, it sacrifices itself first, so it spares the vitamin E so it can go into the animal system, meet the vitamin E need for the animal, improve the immune system, and in the best case scenario, have a higher vitamin E status in the meat coming out of that animal, which has the potential to increase shelf life, would be one example. Another example is when you look at the oils and meals going into diets. Again, those are energy sources. We put the antioxidant with those energy sources, ideally as quickly as possible after production, so that stabilizes them at that point, and again gives the animal the full benefit of those, as opposed to losing energy through oxidation prior to the time the animal gets the benefit of that in their dietary system.
So that is one way that some producers are utilizing antioxidants. Here's our last bit here. Natural antioxidants include vitamin C and vitamin E, beta-carotene, selenium, and then there's a bunch of synthetics, those ones that they were showing us on there, those brand name ones. Those are synthetics with a lot of vitamin E in it. There are three main classes of antioxidants. We've got free radical quenchers. Those are just going to react with free radicals that are in the system. So an example, we've seen this type of reaction before. We have a carboxylic acid radical. It's missing a hydrogen, so it's got an extra place it really wants to bond with something. So we're going to react it with an antioxidant. That's what the A stands for there. An antioxidant has a hydrogen bonded to it that it can give up to the carboxylic acid radical. So we get, as a product, carboxylic acid. And then we have an antioxidant radical that can then bond with something else. We also have chelating agents. It's where we form stable complex ions with transition metals. It's going to reduce the occurrence of free radical reactions. And finally, we have reducing agents, just dealing with that oxidation reduction that we talked about at the end of last school year. Reducing agents are electron donors, and they are going to react with oxygen and the autooxidative hydroperoxides. Now, all of this and then some can be found on page 421 to 427. Near the end of all of that, it talks about these antioxidants, and it talks about the advantages and disadvantages of using antioxidants. Make sure you have read through and understand those